So I think in the interest of time, I'm just going to go ahead and get started. And if folks miss a little bit of the beginning, it's not a big deal because I'll save the exciting stuff for later on. So let's dive right in. So what I want to talk about today is the new Hypar Grasshopper functionality. We just launched this basically last week and have been super excited about it. Basically, we are introducing the ability for you to write functions on Hypar with Grasshopper. Now, in order to explain what that means, I'd like to talk a little bit about what Hypar is. This will be just a few quick slides, and then we'll dive into the meat. So for those of you who are maybe new to the Hypar world, I wanted to just kind of explain what it is. Hypar is a bunch of things, and so I think we kind of are still figuring out how we talk about what Hypar is. But first and foremost, it's a way to capture and share knowledge in architecture, engineering, and construction. It is a web-based computational platform for building design. It's a scalable cloud service for parametric architectural modeling. It's a toolkit for developers who want to build applications in the architecture, engineering, and construction space. And we're not quite there yet. We want it to be a marketplace for people to share their specialist expertise as algorithms. So in theory, you should be able to post your amazing structure generator function on Hypar, and maybe other people will pay you to use it. Philosophically speaking, Hypar is design first. It's really important to us that it be a platform where design can happen. It's modular, composable, and modern. We're really trying to make the experience of building generative design systems on Hypar to take advantage of all of the latest and greatest techniques of software development. Hypar is transparent. We rely on a common platform. We use a lot of open data, open standards, and where possible, even open source. A lot of the core code of Hypar's BIM library elements is, in fact, all of that library is open source. We're cross-platform, collaborative. We integrate well with BIM and other BIM platforms. We're extensible. We're something that you can build on top of. We're scalable thanks to running everything on the cloud. And I think maybe most importantly, we're crowdsourced. We're really interested in making a platform that's rich because of the contributions of people around the world using Hypar. We're a place where you can put your expertise to work. So really briefly, I want to introduce 3 core concepts of Hypar, and then we'll get to the demo. So the kind of building block of everything around Hypar is the element. So elements is our library, which I mentioned earlier, for representing building elements. We call it the smallest useful BIM. It's a way to represent floors and beams and columns and facade panels and other things. And it's also a geometry library that allows you to work with those things. We developed our own library because we needed something that was open source, something that was small and fast, something where we could attach arbitrary properties to these elements, something that can be written to other formats like GLTF, JSON, or IFC. It's extensible. So you can add your own types here. This little ... at the end, and I'll talk about this a little bit more, indicates that you are actually able to add new types of elements to our system without changing the code. Every element is really just a collection of geometry and data, and we provide the kind of base concepts that you can use to construct these building entities. The next concept I want to introduce is the idea of functions, and what we'll be seeing today is a lot about functions. So a function is effectively a piece of logic that's responsible for one whole building system. So that might be, the structure system or the facade system or, some component of an MEP system. And a function is kind of like the unit of computation on Hypar. So a function, you can think of it a little bit like a Grasshopper script in that it has inputs, it has data that it takes in order to run. And those can be both numerical or data-oriented inputs or dependencies on other parts of the model. So you can build a function that depends on, the envelope in the model or the floors in the model or the columns in the model. And one of the things that makes Hypar really powerful is the ability to interrogate the other parts of the model as you're developing that logic. A function is responsible for producing more entities or elements in the model. So a function outputs elements like beams and columns, let's say, and it can also produce numerical outputs or data outputs. So maybe you want some performance measure out of your function. You want to know, the maximum beam length or the total weight of the structure or whatever that can come directly out of a function. And the third and final concept I want to introduce is the workflow, which is basically nothing more than a collection of functions. It's the way that we put functions together and make them do useful work together. So the coolest thing about workflows on Hypar is that because of the way functions are defined, functions can all talk to each other automatically. They can pull what they need from the other functions in a workflow. And so there's the ability to just compose these relatively complex building systems by using these kind of modular individual functions. So maybe I've decided I don't like this envelope function. I should be able to swap it out for another envelope function or even a different one and not disrupt the overall logic of my workflow. I think we've probably all experienced when working in tools like Grasshopper, sometimes it's really difficult to take out some piece of the logic and swap it out with some other piece of the logic because Grasshopper doesn't have great concepts for what we call encapsulation, the ability to kind of like define clear boundaries around the responsibility of one system. But Hypar is designed to do precisely that. So up till quite recently, all Hypar functions were written as C# code. So you would write a C# function and you would push it up to Hypar and it would execute on our cloud. But as of very recently, and this is going to be the focus of today's webinar, we've introduced the ability for you to write functions in other ways, which include Excel, which I'm not going to talk a lot about, although it's really cool. You should check it out. You can basically take an Excel spreadsheet and turn it into a piece of a generative workflow, which is really awesome. And Grasshopper scripts, which we will talk a lot about, which basically allows you to describe the logic of the system you care about with a Grasshopper script and then put it up on Hypar's cloud and have it talk to all of these other systems. So without further ado, let's jump in and let's look at a demo. So first, I just want to show kind of like the core Hypar demo, like how does Hypar work? So I'm going to pull up Hypar here. And the other thing I'll mention while this is loading up is that Hypar is currently free. It won't be free forever, although we intend for there always to be a sort of free tier where anyone can play around and explore and start using our functionality. And so that means anyone can sign up. I highly encourage you to go to hypar.io and create an account. It costs nothing. We're not going to be charging you anything, and you can start to play with everything I'm about to show you. So someone in the chat mentioned Python. We are also looking at the ability to author functions in Python. We actually have it working. It's just not like fully fledged yet. So keep an eye out for that functionality in the future. So I already mentioned the ideas of sort of like functions and workflows as core concepts of Hypar. This is where my functions live. These are functions that I've authored, which are private for me, although I can also choose to make them public and then other people can use them as well. And then these are workflows that I've created that collect those functions to do something useful. So let's go ahead and create a workflow. I'm actually going to start with one that I already set up because I basically just picked a site. And you'll see that this workflow has a function in it already. This function is called location. And with that location function, I went and I picked a site. And you could do this from scratch in your own workflow by going to look for the location function and clicking insert and then picking a location on the map. It's as easy as that. So let's go ahead and develop a new building design right on this site. So I'm going to add a few more functions. We need a building envelope. So I'm going to go search for functions that create envelope. There are a bunch of these. I'm going to use the one called envelope by sketch. I'm going to draw a polygon, which is one of the inputs that it needs. And I'm just going to sort of draw a footprint here. And let's make it a little more interesting than a rectangle. We'll go save. And this is going to go ahead and run that function, generate an envelope, and I can tweak the parameters of this envelope just like I would adjust sliders in Grasshopper. Now, one of the things that's really cool about this is that Hypar allows you to take basically any parameter, any one of these controls, and sample it if, maybe you're not sure what you want the value to be. So maybe we want to test different values for the setback interval and the setback depth. I can just click sample range, and because we're running on the cloud, we can just in parallel spin up 20 different alternatives of this that choose different values for those inputs. So I can scroll through and see maybe I like this variant the best, and it'll load that right up. And you can do all of that with Grasshopper functions as well. So let's just drop in a few more functions. I'm going to create some floors. One of the things that's really nice about the way functions are defined is that they express what they need. So this function needs levels in order to run. So I get a little notification, I'm missing levels. I can just click this, and the function library will suggest to me all of the functions that might satisfy that dependency, that might create the levels that I need. So I'm going to use levels by envelope. I'm going to drop it in. I'm going to change its parameters. That seems a little high. Units are in meters. Eventually we'll probably have like support for other unit systems, but right now everything on Hypar is in meters. And so it's going to generate those levels, and it's going to generate floors from those levels. I'll drop in a facade, drop in some structure, and pretty quickly, by linking together these intelligent systems, I arrive at a fairly detailed architectural model. Now, it's probably no great shakes from a design standpoint, but that's why we need all of you, is that we need there to be a library of really exciting functions that do interesting and different things and that take different approaches to facade design and different approaches to structural design. And we believe that with the new Grasshopper functionality, it should be really easy for anyone to contribute one of these new pieces of logic. So let's jump into the Grasshopper stuff. For this, I am going to switch over to my Windows side. One more exciting technical hurdle. Let's see if we can get this to work. The reason I'm switching over to Windows, most of what I'm going to show actually does work on Grasshopper for Mac, but there are just a few key pieces of functionality that don't work. So I'm going to demonstrate it on Windows, but most of what I'm going to show does work, in fact, on Mac Rhino as well. So when I want to build a Grasshopper function for Hypar, I have to do a few things above and beyond just the regular Grasshopper definition. So, but I'm going to build the definition first. I'm going to make something really dumb, and then we'll get into something more advanced. I'm going to make a center box with some sliders for X, Y, and Z. And this is basically what I'm going to publish. I want this interactive box, the sort of hello world of architecture, of 3D modeling. I want this to live on Hypar as an interactive function. So I need to do a couple things. The first thing I need to do is use the Hypar function setup component under the Hypar tab. Oh, and I should have mentioned, in order to get the Hypar plugin for Grasshopper, if you're in Rhino 7, you can just type package manager, and it'll pull up the Yak package manager. If you're in Rhino 6, you can do the exact same thing, except you need to type test package manager instead of package manager. And even though it looks like it won't autocomplete, it will work. So if you're on Rhino 6, just type test package manager, and then this dialog will come up. You can search for Hypar. You can find the Hypar plugin and just click download and install, and you'll have it for Grasshopper. So I already have it installed. I'm going to grab the Hypar function setup component, and I'm just going to give this a name and a description. So I'm going to say webinar box, and I'm going to give it a description, makes a box, plug that in, and I'm going to also tell Hypar that these sliders are meant to be inputs to my function. So I want to actually see them in the Hypar interface. So for that, we're going to use the function input component. And this just wires in. There was a question about Food for Rhino. Yeah, actually, we are up on Food for Rhino now. It's Food for Rhino takes forever to approve new plugins that are posted. So we're just waiting for them to approve us. But it is up there. But you can use it on Yak today. So with function input, I can plug in the sliders that I want to be my inputs to the O input for input object. And I'm just going to make 3 copies of this. It's going to automatically infer the name of the input to put on Hypar from the name of this slider. So because this says X, Y, and Z, my inputs are going to be called X, Y, and Z. And I'm going to, let's just see, I'm going to also create an output. I basically have to tell Hypar what I want to show up on the web interface. So for that, we're going to use model output. And I'm going to give it a name. I'm going to say this is my my simple box. Actually, let's just call it box. This usually represents like the type of stuff you're creating. And there's a more complex thing that I'll show in a bit. But when you just want to dump some geometry from Grasshopper into the Hypar interface, the easiest thing is to turn it into a mesh. So I'm going to convert my box to a mesh by passing it through a mesh parameter and pass that into model input or model output. And I'm going to go ahead and save this definition to my desktop as webinar demo. And this is where the fun comes in. So I'm going to go back to Hypar. I'm going to sign in. And under my functions, I'm going to click new function, new Grasshopper function, and I can just drag and drop that file I just created. It'll actually like read all of those special Hypar components out of this file so that it knows the name and the description and the inputs and all of those things so that it can run on Hypar. Sometimes it takes a minute. And then when it's done, I'll just click publish. So we can see it's loaded the model output, it's loaded the inputs, it recognized the name and the description. I can also edit these things here, although I think it's easier to do it in the Grasshopper script. We'll hit publish function. And then this is now a function on Hypar that I can use. One thing to note is that these functions are private until you decide to make them public. So you can see this private checkbox is checked. That means no one else can see it. So you can feel free to experiment without, polluting the world of all of these functions. But we also highly encourage you to share cool functions that you've built by making them public so that other people can try them out and use them in their own workflows. So I'm going to create a new workflow, like blank workflow. And I just realized you can't see my cursor because of the way I'm doing this. Let me just turn that on. So I'm now going to search for that function that I just created, which is called webinar box, and click insert. And just like any other function, it'll show right up. I have access to all of the inputs. I can control them, and it will recompute on the fly. If I want, I can use sample range on this. So maybe I want to test it across a range of Y values. And it's actually going to run your definition in parallel and generate a bunch of alternatives, which is something that I think is actually like out of the box, really, really useful. If you don't want to animate slider or whatever else on your Grasshopper script, you can just automatically sample a bunch of possible values for your script by using the sample range functionality on Hypar. So that's the super bare bones hello world of how to create a function. Next, I want to build one that's a little more involved. I think we're actually making really good time though, so I wanted to pause for a second and see if there are any questions about what I just showed before I move on to a more advanced example. And in the meantime, while I wait for the stream to catch up to what I actually have just said, I will also just pull up Rhino and spin up a new definition. Oh, also, I'm faking my Hypar shirt because this is just a sticker. We don't have swag yet, but we will when we hold the contest for the world's best Grasshopper Hypar function. We'll send the winner a shirt. That's not a real thing. Don't quote me on that. So, okay, I'm gonna keep an eye on the chat and look for questions, but if there aren't any, I'm just gonna plow ahead. Oh, perfect, here we go. What's the output file of Hypar? That's a great question. So in general, we think of Hypar as sort of a destination in and of itself. You can, you could just share this workflow with someone else using share. But if you need to get it into another platform, of course, you'll want to be able to export it. And so the export button here in the dialog allows you to download in 3 different formats, and we're working on more all the time. The GLTF is sort of like a really web t-shirt, a web format, web 3D native format. IFC, of course, will work for like importing into Revit. And JSON is sort of like the most native representation of Hypar elements. And you can actually import this JSON data into your Grasshopper workflows as well. I'll show that in a bit. So QuantQuant has a great question. Is it fair to summarize that Grasshopper Hypar plugin as a way to create that encapsulation you said that GH historically lacks, just for understanding? And I would say that is a big component of it. That's not the only thing. I think there's a lot that this brings to the sort of Hypar or to the Grasshopper ecosystem. But encapsulation is a big one. And what we mean by encapsulation is basically like when you're developing software, you want to make sure that the pieces that you're working on are kind of live in a black box. They kind of are, there's a clear interface and you only need to know a few things in order to use it. You don't need to know all of the logic of what goes inside. And I think you've probably experienced this working with Grasshopper scripts shared by other people, is that like, if you don't know everything that's going on in that script, it can be really difficult to use. It can be really difficult to adapt to other workflows. And so I think one of the benefits working this way, using Grasshopper in this way in tandem with Hypar, is that it forces you to basically, I'm wrong, but if you designate a numerical output using the output component, then you can sort by that as well. So you can basically like test the outputs of every function against that performance. But I think there's a lot of room for us to grow around sort of how we drive the inputs to all of your functions based on various performance targets. What are the supported GH plugins and CH modules? So yes, there is a list of what's supported. So we are currently with the Grasshopper functions. You can use human, clipper, wombat, jswan, tree frog, and we just added a handful more, mesh tools, mesh edit, and we definitely haven't been exhaustive with that. We don't want to support just like arbitrary C# code just yet. We will in the future, although it might be more of a premium feature. But there's a risk involved with just allowing anybody to execute whatever code on your server. So right now we have sort of a curated allow list of plugins. So the other question is, how can I export final geometry back to Rhino or Revit? So I will show that a little bit later, at least as far as the Rhino stuff. But for Revit, your best bet currently is to download an IFC, which Revit can read. This is also probably hidden under my head. Let me just see if I can move this real quick. So you can see there's this export button, and there are some export options here. So if you want to download an IFC, Revit can read that, but we're also working on other kinds of Revit integration. Can GH hyperfunctions have outputs that provide dependencies for multiple functions out the other side, i.e. a script that takes in an envelope to create floors, but also cores and then tracks both? Yes, absolutely. Grasshopper hyperfunctions can provide dependencies for multiple functions. In fact, all hyperfunctions work this way, where they can depend on multiple things and produce multiple things that various downstream functions can use. So I'm going to take one more and then I'm going to dive back into the demo. So can we modify the Grasshopper algorithm with Hypar? Currently, no. Currently, the logic of the function is sort of locked away and you have to edit it either, in C# or in Grasshopper. But we're very interested in figuring out ways that maybe you can actually like build up the kind of core logic of a function also in the Hypar user interface. Okay, I'm going to tuck my head back over in the corner, and we can build up a more exciting example. And I think this example will also address some of the questions that have come up. So what I want to do is actually build a function that participates in the Hypar ecosystem. So I want a function that will be able to play with this this setup I set up earlier. I want to maybe create a different logic for how you would build an envelope. So I'm going to go ahead and delete envelope by sketch. And all these functions are telling me, help, I need envelope. I'm dependent on envelope. So what we want to do is create a Grasshopper function that will create a new envelope that we can drop into this workflow. So let me show you how that works. So I'm going to grab the Hypar function setup component again. I'm going to create, this time I'm going to use sort of like a stacked box massing. And I'm just going to give it a quick description. And the next thing I have to do is I mentioned earlier that Hypar functions and elements are extensible. They can use custom types of information. And so one of these functions that's missing envelope is looking not only for something called envelope, but also something that is of the envelope element type. So if you open one of these functions and click about, you can see that this is the types that it uses. And one of those is envelope. And if I click on this, I'm going to get this link to this kind of crazy looking text, which is what we call a schema, which is basically like a description of a custom element type. Now, this might seem a little intimidating. I wouldn't worry about it too much. You don't actually have to like author these unless you want to. But the thing that's really powerful about Hypar is that if you want to create a totally custom type, you can just write one of these documents, and then all of the parts of Hypar's ecosystem can point to these schemas and be aware of your types as though they were, native element types. So it's as if you could, make a blob type and just inject it into the Revit toolbar or something like that. So I'm actually going to need the link to that, even though I don't need its specific text. So I'm going to right click where this is envelope and say copy link. And in order to make our Grasshopper ecosystem aware of this custom type, I'm going to paste it into a panel. So I'm just going to paste that text, which is the URL to that schema file that I just showed. And I'm going to plug it into the third input here, element type schemas. And I can add as many of these as I want. And this is going to go fetch that schema and load that type into the Hypar ecosystem so that now I can start to do things with it. Like if I want to create an envelope, which is what I want to do right now, I can go to Elements, Construct Element, right-click it, and Envelope is now one of my options, where it wasn't before. So if I define another type, I can just plug in a link to wherever it's described, and I can create that as a native component directly in this Hypar workflow. So I'm going to need to create an envelope so that it can participate in this workflow that needs envelopes. And I'm going to do this by taking in a kind of profile for the plan. So I'm going to just grab a reference curve. I have a polyline drawn in Rhino, set one curve. In the same way I designated a slider as an input by using the function input component, I'm just going to plug this curve parameter into the input component, and it recognizes that that can be a polygon. So now I've got my kind of base profile. And what I want to do is kind of randomly move it. And I don't know how many of these stack boxes I want. So I'm going to make a slider that goes from 1 to 5 to 10, let's say. And I'm going to say number of boxes. And so what I want to do is create some random positions that can be the centers of this. So I'm going to use the populate 2D component, and I'm going to pass it this curve. And right now it's generating like 100. I really only just want however many points as I need for every box. And what I want to do is make multiple copies of this that are basically centered at each of those points. So what I'm going to do is take the center of the polygon as it currently exists, take the vector, this is all just Grasshopper stuff, the center of that polygon, the vector from that center to each of these points. And then I'm going to move these to be the kind of baseline for my boxes, for my sort of stack boxes. And if I have 3, I have 3, and so on. Now, these are kind of hanging out a lot. I imagine this kind of like, you know, like your typical stack box massing, probably doesn't have quite that much cantilever. So what I'm also going to do is scale the points about the center. And I'm going to make the control of that also a slider. So I'm going to go from 0.01 to 1.0. And now these are going to be the points that I plug this vector into. So you can see if the value is very low, those will almost not overhang at all. And then if the value gets higher, they'll sort of spread out. So this is also going to be an input. So I'm going to make some function inputs for this and for this. And so the next thing I need to do is actually extrude these up in 3D. So I need a couple more sliders. I'm going to say my box height will be like this. Whoops. Box height. Also make that a function input. And I'm going to also create a series where I'm going to use the number of boxes as the count of the series and the height of the boxes as the step. So this will be my sort of Z elevations for every one of these. So I'm just going to plug this in, make a Z vector from each of these, and then I'm going to move my profiles yet again. So now these are basically the sort of bottom profile of every one of my stack boxes. And if I just extrude it by the box height, we need to plug that into a Z, of course. Then I'll have my stack box massing that I want. Now, before, the way that I put geometry into the model output, remember, was that I converted it to a mesh. But if we want other functions to be able to consume the geometry we produce, we need to actually create native Hypar elements. So that's what this component I showed earlier, construct element, is for. So we actually want to construct an envelope element. And so we have pretty much all the information we need to do that, minus 1 or 2 things. So I'm going to take all of my profiles here, and I'm going to plug those in as the profile. I'm going to take these heights, which I use to make my Z vectors, and I'm going to make those the elevations of every envelope. I'm going to use the box height and make that the height of every envelope. And then I also need to supply a geometric representation. Custom types require you to basically like define the geometry that is going to be represented by this thing. So for that, I'm going to create a representation using the representation component. And into this, I can feed any sort of solid. And right now, you know, it would be nice if I could just plug in my extrusion directly, but in fact, I'm going to have to create a special Hypar extrusion. This just limits us so we don't have to handle like every imaginable, you know, shape that you can create in Rhino. So we're going to create an extrude, and we're going to use basically the same information. This is going to be the base profile. This is going to be the height. This is going to be the direction. And I'm going to plug those in. And let's see if that worked. Oh, we went a little big. Let's try these guys. What am I missing? Oh, I know why. Because I'm feeding in all of the representation. So in fact, I really want to graft this list. Let's see. Yeah, let's graft this and flatten this. And we've now got our sort of 5 representations, which are our 5 extrusions. And each one should have a, oh, I've used the wrong height, that's why. Oh no, that should be the right height. Hold on, I built this one earlier and it worked fine. Bear with me for a second. Oh, I know why. It's multiplying by the vector. I should just supply a Z, and now I can use these moved profiles and everything should be happy. Okay, there we go. So I've created my envelope. I can turn back on preview here. Now it previews here in gray, which is also how it'll show up in Hypar, just like the box we created before. I also want to give it a material. I can either construct a material or I can actually just pass it a color swatch. And it will automatically convert that to a Hypar material for me. I'm gonna pick a color, usually do like a nice transparent blue for my envelopes. And I'm gonna designate this as the model output. And I'm gonna call it envelope. It's very important that in this step, whatever text you put here for the name of the model output has to match whatever text is being looked for by each one of these functions. And I'm gonna plug in these envelopes. And I'm going to save this as my stacked box massing for webinar. And I'm going to go home. I'm going to go new function, new Grasshopper function, just like we did before. I'm going to grab that Grasshopper definition. And it's going to load all the information. This time we should see that it's designated that model output as envelope. And we should see all of our sliders represented as inputs. And so there we go. We've got a curve input, a number of boxes, oh, I probably should have named that one. That's probably one of these other sliders. The other thing is that I can just go back and make edits to my Grasshopper script. So in fact, let's just do that. I just didn't name it properly. This is meant to be the overhang factor. And let's just call this the like floor boundary shape. And like that. And we'll save. And we'll drop it back in. And this time it should go a lot faster. Effectively, this is happening on a little like box in the cloud that takes a minute to spin up, but once it's spun up, it should go pretty fast. So there's our envelope, our inputs. I'll hit publish function. And I can hit close. And now, sometimes you need to refresh in order to get your function list to show that in the workflow. But I can just go ahead and add function and go look for my stacked box massing, which was this one. And you can see that right away it satisfies all of the dependencies. And it's just missing some input because I haven't drawn a polygon yet. So this time I'm going to draw a little, let's make it kind of like a parallelogram. Save. Not sure it's structurally sound, but it does appear to work. So maybe I can just scooch back that overhang a little bit. Let's tuck this guy back. And you can see that this Grasshopper function is just participating in, a workflow just like any other, which is what I think is one of the most powerful things. It just was able to grab the envelope data and generate some levels, generate some floors, generate a facade. Maybe we can drop in some columns. There we go. Maybe I'll hide that so that we don't get that Z fighting. Robert wanted to know, what if your solids were not simple extrusions? Can you just pass a solid? So currently, no. We're working on building out a kind of like full set of solid functionality, but right now there's no straightforward way to pass like a Rhino or Grasshopper solid directly. We need to construct it ourselves. But there is a notion of like voids as well as solids, although I don't think it's like fully implemented yet. The other thing that's fun about this, we can, let's say, maybe we'll sample across the overhang and the box height, and we'll get a bunch of options. Go. This is some sneak preview functionality, but you can also let's do sort by number of boxes, and actually let's do overhang. You can. This is not available in for everybody yet, but this is something we've been playing with. If you click the GIF button, it should generate an animated GIF for you of all of the options that you generated. Hopefully it'll work. Oh well, I guess that part is not going to work, but that's okay. As I mentioned, that's beta functionality. So I want to leave the remainder of the time for questions. I know that I went through that particular example really fast, so I'm happy to return to any of the details. But just in general, I'm really excited for people to start playing with this stuff. I think there's, one of the reasons strategically we made the decision to support Grasshopper functionality is that we know how many incredible scripts there are out there, how much time has been spent and how much energy and how much intelligence is locked up in these Grasshopper scripts that live at firms and that live on people's desktops. I think in a way, enabling those things to run in the cloud and to talk to each other is a way of sort of freeing them and, allowing them to reach their full potential to actually change the way design is done. If you've really crafted the world's most sophisticated, elevator generator, then, everybody should be able to use that. And it should benefit you that other people are using that. Go ahead and tweak this guy a little bit just for fun. Managed to get it done in under an hour, even with the technical difficulties. I'm pretty pleased with that. I am happy to stick around beyond the hour if there are additional questions. Actually, while I'm waiting for questions, I'll pull up a workflow I've been working on here. Oh, great. Question from Mike. How easy is it to share a workflow with someone else? It is this easy. So there's a sharing button. I can make it public, in which case anyone with the link can view it. Or I can invite specific people to view it. So, I can send, I know that's probably not your email address, but I can send a link via email, and then they can get access to that workflow. And then when they get it, they have the opportunity to duplicate it and manipulate it and build something on top of it as well. There's a question, can Hypar connect with Speckle? So not currently, although we're good friends with the Speckle folks and we really believe in what they're doing. We're really excited about everything that they're building, and we would love for there to be a Hypar Speckle connection. Obviously there are a lot of common aims around open standards and open data for AEC, and so we would love to work closely with them. There was also a mention earlier about Ladybug, which is another team that we have a really good relationship with and would be really excited to get all of this stuff integrated with Pollination Cloud, for instance. I think that's one of the things that's really exciting about this development generally, is that we're starting to see all of these really cool web services and web APIs emerge, and to be able to have something like Grasshopper integrated into an ecosystem that's sort of web native and can talk to all these APIs and can rely on live data and stuff, I think is really exciting. Yeah, there was a question about, oh, Yuko, you made it. Shout out to Yuko, for whom it is about, what now, 4 in the morning? Who, I don't know if she stayed up late or got up early to join us, but she wins the prize, I think. Yeah, Robert, I think the sort of void solid stuff is not totally implemented yet. I think it works in some places and not in other places. But Yeah, it's definitely on our near-term roadmap to get, the kind of full support for that stuff. Are the parts inside a creator's algorithm hidden when made public? Oh, this is a great question. So the inputs and the outputs are the only visibility. So that's the other thing that I think gives people a lot of security, is that this is an opportunity to share your logic without giving away all of the IP behind how it was developed and how it works. So other users of your function only see the inputs and the outputs, and they have no access to it. It's living protected on our cloud, such that the only person with edit or read access is whoever created it. That's been a real benefit to our like C# developers, is that they can write some complex code, but there's not even any risk of like reverse engineering or decompiling it. It's a kind of like safe way to share your logic. So Raphael has a really good point. In my experience using computational design and early conceptual design, I frequently have to go manual and override some of the hard logic with some sort of dirty geometry to quickly visualize. So yes, this is really important, and we know how important it is to get this right in the Hypar ecosystem. And I will say we're probably a little ways out from supporting it, but it's an idea that is super, super important to us. It's something I've been talking about since even before I joined. How important it is to have opportunities for direct manipulation that are, kind of on the same plane as generative systems. So, we don't have the perfect solution to that yet. I think one version of it is the kind of platform integration that Ian has been building that allows you to basically like call up, like use your local environment as a part of a Hypar workflow. So he's got some demos going. I don't know if I'm allowed to talk about this, but he's been building some really cool demos where basically like, running locally, you can develop some logic or interact with it in a modeling application, and that application basically like sits just like another function in your workflow, which is a pretty cool concept. I also think over time we'll add a lot more direct manipulation capabilities in the platform itself. So the ability to, use the generative function to build the envelope, but then there's like a, another trim where you just like slice off the top with a kind of manual operation that just sits as part of the stack. And I think what's cool is the potential for all of those manual interventions to be represented in a way sort of parametrically, so that even if I make that manual trim operation, I could do it very easily and streamlined in the same way I would in a modeling application. But if I made a change to my kind of core geometry, I should be able to, have that update. At the there, that's not always possible, but I think we can build this in a way that allows kind of direct or sort of manual overrides or direct intervention to coexist in a fruitful way with generative systems. Rob wants to know if there are MEP elements or if he'd have to create his own. And the answer is right now, I would say probably you need to create your own. I would say that, Eric, one of the developers on our team, knows a ton about MEP engineering, and so he would be a good person to talk to about some of those opportunities and if there's anything that exists. I would also say there are lots of MEP oriented folks on the Hypar Discord, and we're really interested in setting up an ecosystem where maybe you can get together with a few folks who are working in a similar discipline, and team up on how you might build a useful function or a set of elements or a set of functions that all work together around, say, MEP problems. Drop in some columns, why not? I think I'm gonna stick around a little longer, just in case there are additional questions, but I'll officially wrap it up here. Thank you all so much for coming. Please feel free to hit me up with questions later on. I will give just one more shout out to the Hypar Discord, which is really an amazing community. This is a place where, you know, lots of interesting discussions are happening, and not even like just Hypar oriented ones. We've got a really interesting set of debates going on about the future of the profession, about machine learning and its applications in architecture with a lot of really experienced folks. It's a really cool place to, you know, just talk about the consequences of tools and systems like this. And it's also a great community to, you know, to learn from each other. Yeah, I highly encourage you to join. You can find the link on Hypar's website. So this is actually, we just added this, which makes it really nice. If you go to hypar.io and scroll all the way to the bottom, there's a Discord link where you can join. Is there currently any way to run basic structural analysis aside from manually building a C# code? So yeah, currently I'm not aware of any structural analysis functions, although that's definitely a use case we've talked a lot about and would be really excited to have someone build. There's currently, I don't know of any structural analysis functions. So I'm based in New York. Eric is based in Philly, right? And Matt and Anthony are in Boston, and Ian is in LA. So we're actually a distributed team. And Raphael wants to know, is there some sort of a function DNA somewhat mimicking history modeling like CATIA? So I'm not super familiar with the history modeling functionality in CATIA. You might have to explain a little more what you mean by that, because I'm not sure if we have anything like that. I would say, like, in general, the logic of, you know, history-based systems is just that they preserve a kind of dependency chain. You know, Hypar does that sort of natively, but I don't know if you're talking about something more specific. Could we use GH Hypar to generate visual overlay for performance? Oh, I'm so glad you asked. I hope this one will work. So one of the things that is supported right out of the box is vertex coloring. So if you generate an analysis routine in Grasshopper and just want to like spit the results back, like a, you know, similar to Ladybug or something, you can drop that in. We're also definitely interested in being able to do viz in outputs, although that's not currently supported. It's definitely something we've talked a lot about. And there's a question about regulations, like plot sizes and setbacks. That's also something that, you know, I think, you know, we see so many directions that we can be building functions. So hold on one second. Here we go. We can just view this in context. But here's an example of like a, you know, a really bare bones solar analysis being run on that mass, and that's running in a Grasshopper script. The question about regulations, I mean, you know, that's always a really tricky problem. You know, they vary a lot by region, but we're definitely interested in being able to build out utilities that make it really easy to build systems that take into account things like setbacks and stepbacks and, you know, various like, you know, daylight slope exposure planes and stuff like that that are sort of common in zoning regulations. And, you know, the sort of difficulty is getting that information in a way that's sort of high fidelity for every location. But we think that by building sort of toolkits around that and testing it in a few locations, we can make it easy for function contributors to build their own versions of those things that work in their locales by relying on some of the same toolkits. And so the only limitation with Hypar functions calling external APIs, the location function that I glossed over earlier, this already calls the Mapbox API. The only limitation is time. If it takes longer than 30 seconds to call, then I think it might even be a little lower than that, then we'll time out because the Lambda servers that we use to run all of this have sort of a timeout attached to them, but there's no functional limitation. Like, we're not saying you're not allowed to call APIs. You are absolutely allowed to call external APIs in a C# function. Grasshopper functions, probably you can't unless it's built into a plugin that we already support, at least not currently. Just following up on Raphael's question about the function history, I mean, I think in a way what we've built is a sort of set of function history that is directly related to the elements that it creates. I think the tricky thing is how that relates to manual intervention, like we were talking about earlier. You know, how do you permit kind of direct manual intervention to coexist with the sort of generative system or the history-based system? You know, you see this even in Rhino's history. You know, you'll flow along a curve and then you'll move one of the things and then the history relationship is broken. And I think that there are various strategies for thinking about that. We definitely have not solved that problem yet, but it's something that we're very aware of and would like to figure out a good strategy for, because I think it's going to be really important for, again, any sort of real design-oriented application has to be able to support those kinds of direct tweaks and manipulations. You know, I think one way to think about it is just simply like capturing every direct intervention, every action that's taken in the platform, every command you run or thing you move or thing you do, action you take, is itself a sort of parametric action. Oh, you can't see my Solr analysis. Oh, of course. Now you can. There we go. Thanks for that, Matt. Sorry, I forgot that I wasn't showing the Windows side. But this is just showing the a sort of analysis routine running in Grasshopper, actually, on the mask we just generated. And the cool thing about this too is that, like, because there's a location in this function, it has a latitude and longitude associated with it, so we can use the, like, you know, the geographical information to feed into our analysis. This is not a very sophisticated Solr analysis. I'm just doing some like really bare bones raycasting. We think that the right way to do this is to partner with the Ladybug folks and make a call to the pollination cloud, because they're already building, you know, the kind of like robust, validated systems for doing all of this stuff. So, you know, I think that we would love to see pollination cloud functions start to show up on Hypar, whatever form that takes. Because, you know, we're not the experts that they are in all of the, you know, environmental analysis stuff. But, you know, we'll see how that evolves. That there's definitely an interest in being able to do that kind of thing. Jake has a really good question about liability. So, you know, I think there's no easy answer to this question. The question is basically like, you know, if someone uses a function for, say, structural engineering or whatever, and that function says something wrong and the building falls down, like, who's at fault? I think for now, you know, nothing about the platform says, you know, I hereby take on the liability of this, you know, as like the algorithm is not saying I'm your engineer, and, you know, the algorithm is not saying I'm your architect and stamping a drawing. So, you know, from a legal perspective, you know, it has no liability relationship, and the sort of dumb answer, and probably the one that will remain true for a long time, is that, like, humans have to check it, humans have to sign off on it, you know, humans who are licensed and all of those things, and so that probably won't go away for a long time. However, I think in certain domains, at least, there's the potential for certain kinds of questions to be answered systematically with enough rigor that you could actually, you know, trust them enough, but that they could actually, you know, serve a legal purpose. But I think we're a really, really long way from that being something we have to confront and deal with. I think that, you know, like, at the end of the day, whoever's using this workflow and who's ever using it to communicate and whoever's using it to produce drawings remains, liable for whatever decisions they've signed off on. So I don't think Hypar may, really adds anything all that different to the equation. At least not yet. Yeah, I'm not sure, Anthony would be the one to ask about this. I don't know what our terms and conditions says about liability, but, since we're just a platform, obviously we're also furnishing a lot of functions, but, we make no guarantees as to, the structural feasibility of, of those things. So I'm sure there's some language in our terms and conditions that asserts our lack of liability for that stuff, but I couldn't tell you off the top of my head. Yeah, no one blames the pen. I like that. I might steal that. One other thing I'll demonstrate here, just because it happened, is that one of the things we've found, this is true in a lot of Grasshopper cloud development processes, is that it's really hard to debug. This is something that I ran into when I was building a lot of cloud computation stuff for at WeWork, is that debugging is really difficult. So if there are any errors or warnings on any of the components in your Grasshopper script, those will be exposed here. So I can actually see what errors were thrown by the components in my workflow, which makes it a little easier for me to debug. This icon is, I glossed over it. It's called isolate or isolate in context. This is just a view mode for this function where I can basically say, only show me the results of this function, or only show me the results of this function in the context of the other stuff. Everything else gets faded out. We'll pick another one of these while we wait. I like that. Something low. It's not actually the Lambda CloudWatch errors. It's the Grasshopper errors themselves. So if any component enters an error state, if I plug this into that or whatever, these little bubbles or whatever, will show up. And we do expose other errors, but we try to make sure that we only show you the errors that you can actually do something about. So if there are certain kinds of execution errors on a C# function, will also show up here. So Andrew has a really good question. Could someone take over the canvas to render not a building if their script was something more art than building? Love this question. As you can imagine, this is near and dear to my heart. Currently, we don't support rendering anything other than 3D models. So, there's nothing that says that your model has to represent a building. But it, we have definitely steered the functionality towards building design use cases. But we have talked a lot about ways to allow function authors to supply custom UI. If the question is, could you do an art project with Hypar? The answer is yes, you totally could. But I don't know what it would, it would still be rendering something 3D. You don't have total custom control over the canvas. We do really want to make it possible to render custom output visualizations dashboards and things like that from functions. I think that'll probably come sooner rather than later. Would that open D3 integration? I mean, I'm not going to make any promises. And yeah, interiors definitely touch on the manual integration problem as well. You know, I think like to me, one of the things that really excited me about Hypar, actually, like before I joined the company, was the fact that like this was part of it. Like you could actually like living right alongside a generative system is the ability to just draw stuff. But I think we have a long way to go as far as all of the kinds of things that you might want to draw. You know, I think at some point you're just going to need to place elements, and you know that could just be some sort of a point input that links to some function that generates an instance of a thing. I also think there will probably be sort of like sketch-based interaction for other kinds of layout problems, like you know maybe I manually draw a line and it becomes a row of desks and things like that. So I think there, you know, the sort of geometric inputs to functions is just the first piece of that equation, but I expect that over time we'll see those functionalities grow quite a lot. So there was a question about multiple buildings. So this is a little bit up to the authors of the function, but I have a workflow, I think here. It's on another user. Let me see if I can just pull this up real quick. Myself, let me find master plan. Let me actually do this with my API. About like being able to do multiple buildings, I've been working on a, where'd it go? Master plan. A little demo that's actually primarily composed of Grasshopper scripts. And this will take like a larger site and then generate multiple masses on that site, and then use some of the same things we've just seen to, you know, generate floors. And this is actually, this facade function is running entirely in Grasshopper. You know, you can imagine being able to introduce like all kinds of interesting, like this is about the dumbest, like, you know, aluminum curtain wall imaginable, but you know, you could imagine starting to add all kinds of, you know, really interesting and exciting facade systems that you can just swap in and out. There was a question about social distance based functions, which I think is actually a really good one. There has been some chatter about this on the Discord. Actually, some folks have been building really interesting generative models about social distance. And you know, I would be really interested to start seeing those show up on Hypar. Playing around with this function. Yeah, we need CSS for building design. No, God, I've spent so much time in CSS over the last however many months. We've got to be able to do better than that. Let's do these. Yeah, thanks to everyone for coming. I will continue to stick around, but you are more than welcome to drop off now. Please try out the functionality. put it through its paces, build some functions, tell us about what you've built. We would love to promote any of the work that you've done on Hypar. If you build something cool, we want to show it to the world. And yeah, thank you all for spending this part of your Friday with me. Yeah, being able to like actually there's a bunch of functionality around tables coming in really soon around our Excel work. Being able to visualize tables, being able to like interact with tables, see tables of elements that are linked to the model, things like that. It's going to be really cool. I can't wait to see it. I'm just going to keep playing with this function until everybody leaves. Yeah, the other thing I'll say is we're also very excited for you to try this out in a real project. And, you know, this is a really good time to start playing with Hypar because we're so hungry for feedback and for feature ideas that will contribute to work done. So like if you are on the fence about whether or not to try this on a real project, like try it out, let us know that you're trying it out, and we will do everything in our power to make sure that you succeed, that we will help you, you know, solve problems, we'll add new features that you desperately need. You know, I can't promise everything, but you know, we will do whatever we can to make sure that that's a successful experience for you, because we're really excited about it. We really believe that, you know, the plumbing is there to support all kinds of interesting work. So, you know, please try it out and let us help you if you need it. Thank you for coming, Yuko. I can't believe you stayed awake for this. I'm amazed and touched and honored. If anyone's been to one of my webinars before, was the audio any better? I have my like fancy new mic. I'm curious if it was an improvement uh, over previous live streams. Yeah. Oh man, Raphael, put that stuff on Hypar. We would be so happy to see that kind of stuff show up. Uh, I know, I believe, and I know that there is just this wealth of computational knowledge out there, and this wealth of incredible scripts that people have built for their particular purposes, for their firms, for themselves. And like, to me, it's a shame that, you know, and I realize that there are other considerations, you know, there's people's IP and, you know, all this other stuff, but I think that one of the biggest reasons why we haven't seen the kind of true explosion of this stuff is that it's so hard to share and so hard to connect, connect to each other's work. To me, you know, I even if, you know, people share functions on the Grasshopper forums all the time, but you know, you download that script and that script is a mess of spaghetti, and it's, you know, even if it's well documented, it can be a real pain to use it, and then it can be an extra real pain to connect to the script that you're working on. You know, maybe your data trees are wrong, or you know, maybe it makes some assumption about your geometry that's not valid, or maybe it assumes that your Rhino model is structured in a particular way. So question about passing data out through an API to display info from the Hypar function. That's interesting. I don't know that we've ever, I mean, I'm sure some folks on the team have thought about this. I've never thought about APIs as output. I don't think there's any reason why you couldn't make a network call from your function that pass that data out to another service. We've always thought about APIs as an input mechanism, but we have not talked much about it as an output mechanism. Now, I think we would be really interested what the use case for that was. And, I hope that, the one thing we have talked about at some length is the idea that actually every Hypar workflow or every Hypar function should itself be able to be accessed as an API. Again, that might be a premium function, or, it might be something that, that is, requires special access, but at least in theory, there's no technical reason why you couldn't just call a Hypar as an API, and build your own front end for it or whatever. So that's maybe another flavor of the answer to your question. Yeah, that's really interesting to do sort of a dual screen view with data going to tables. I mean, we're going to have tables natively in Hypar probably sooner than that will, but I mean, there's really no reason why you couldn't do that today, I guess. There's a question about sharing private functions to someone else. So currently functions are either private or public. There's no sort of in between or shared. There's a way that you can have a team. So, I don't think this is totally rigged up with our enterprise account stuff yet. But the idea is that you should be able to share your function with your whole team. But currently, at least as far as I know, there's no way to just directly share a function with somebody else unless you make it public for everybody. Yeah, I think estimating is a really amazing use case for this stuff. Well, I think I'm probably gonna close the stream now. But I really appreciate everybody coming. And oh, sorry, we have one more question, and then I'll go. Because I particularly like this question. So can we define upload meshes or 3DM models and whatnot as a function input? No, this is actually, no one has asked this yet, and it's a very good question. So a couple things. One, you can, there are import functions of various kinds. So you can take a DXF and turn it into a floor. I think there's JSON to model, which is how you can take Hypar JSON and put any elements just directly into a model. I think that's public. And let me just check. Yeah, you can actually import JSON stuff, and that's how you would get something out of Dynamo or whatever currently. But the other thing that's really cool, which just happened, is that we had a meeting with the McNeil folks the other day to kind of show off what we've been up to. And Will Pearson showed us that you can actually run the Rhino 3DM library within our system. So he was able to read a 3DM file from within a C# function and just generate a Rhino head as a Hypar function. And obviously the end of this is not just generate a Rhino head. It's being able to use the libraries that the McNeil folks have made public to do things file translation and other stuff. So you could absolutely use those kinds of tools to drop in. This is already demonstrating being able to put a Rhino 3DM file in here. Now, there's no way to drop the file path itself in, but there's no reason why we couldn't build a function that would let you drop a Rhino file in here. Okay, now that'll officially be my last question. I have to stop looking at the chat so that I don't keep answering. But if you have further questions, please reach out. I'm easy to find on Twitter and the internet at large, and especially on Discord. We would really love to see you folks on Discord, be a part of the conversation. It's been a really exciting thing, and it's just a lot of amazing folks have joined us there, and the conversations have been really great. And it's just the perfect place to get in at the ground floor and be a part of shaping how this platform evolves. So thank you all so much for coming. Really appreciate it. And yeah, I'll sign off there. Thanks very much.